Okay, just a simple example finding the area of a triangle where you may not be given a base and a height. Let's draw an obtuse triangle here, an oblique triangle if you will. Maybe look something like this. And let's say that we know that the length of this side is 12 centimeters and this angle is 40 degrees, and that this side might be something like 5 centimeters. Okay? And I want to find the area of this triangle. Well, what I need to do is choose one of the two sides that we know to be the base of the triangle. Okay, so that's up to us. The other thing I need to realize is up here I mentioned an included angle. So what I mean by an included angle is that it's the angle between the two given sides. Okay, so it's the angle included between the sides. Alright, so that's what we have here. So let's choose one of the two sides to be the base. It doesn't matter which one. I will choose the 12 to be my base. Alright? So what I'm looking for is area equals 1/2 times base times height. And so I'm choosing my base to be 12. So I've got 1/2 times 12 centimeters. Now I just have to find my height. So I come back up here, and my height is from my base to the point that's furthest away, the vertex that's furthest away, and that is clearly this vertex. And so I have to drop a perpendicular from the vertex to this base. And by doing that, I've created a right triangle. Let's make that a bigger line here, thicker line. I've got this right triangle, and now I need to find the height of my larger triangle, and that is in fact this side of the right triangle. So that's the height that I'm looking for, this length of this side. And since I've got my right triangle here, I need to find a relationship between this angle and the two sides that I'm using here. Okay? And since this is a right triangle, I can use the ratios for the trig functions. So I have the 40 degrees, I have the opposite side, and the hypotenuse. So that tells me I want to use the sine. So I can come over here and I can say the sine of 40 degrees equals the opposite side, the height, divided by the hypotenuse, 5. And I need to solve this for height. So multiplying both sides by 5, I can see that the height of this right triangle, or sorry, the height of both triangles actually, is 5 times the sine of 40 degrees, and that's what I'll put in here. So that is my height, and I use trigonometry to determine that. So now I simply multiply all this out, and it looks like we get approximately 19 square centimeters. Okay? And square centimeters because centimeters times centimeters is square centimeters, and that represents an area.